everyone, it's Alice and we are back today with another GRE video. Today we're going to be going over a few quantitative comparison questions and summarizing some tips that you can use to solve other ones. So the video is sponsored by my private tutoring. More info on that at the end of the video. So in case you are unaware, quantitative comparison questions make up a good portion of the quantitative section of the GRE. And they can be very weird because this type of question is not something that you normally see in your math classes or other places. And the way that they work is this. So you can see on the screen here I have two quantities, quantity A and quantity B. The purpose of this question is to compare those two quantities and decide which quantity is higher. So the four answer choices here are A, quantity A is greater, B, quantity B is greater, C, the two quantities are equal, or D, the relationship cannot be determined. There's no fifth answer choice like there is for most other GRE questions. So the answer to this kind of question looks relatively simple, but as we get into it, you'll see where some of the challenges lie. So one thing that I want to do is go through a few example questions, and we have one here. This one says, in a probability experiment, G and H are independent events. The probability that G will occur is R, and the probability that H will occur is S, where both R and S are greater than 0. Okay, so for this question, it has a little bit of a setup, and then we are given the two quantities. So quantity A is the probability that either G will occur or H will occur, but not both. And then quantity B is R plus S minus RS. So when you look at this, obviously this is a probability question. In order to be able to compare these two values, you need to put them in terms that are comparable. So the easiest thing to do here is probably turn quantity A into an equation like quantity B so that we can compare and see which one would be higher. So when you're looking at this, you want to think about how you can change quantity A into an equation. And you have a few hints here, but what we're looking at is this. So the probability that G will occur is going to be R, because R represents the probability that G will occur, minus the times when G occurs and H occurs. You're looking for the time when only G is happening, but not both. And then you have to add that to the same thing, but with H. So for this, we have S, because S is the probability that H will occur. We have to subtract from that the times when H occurs and G occurs. So what we're going to have left is only the times when H occurs by itself. So once we have this, we can look into it. When you have two things that happen at the same time, to get the probability of that, you multiply those together. So the times when G occurs and H occurs is going to be RS. So for that part of the equation, it's going to be R minus RS. And we're going to add on to that S minus RS, meaning the times when only H occurs. So here we have on the left-hand side the times when G occurs, only G occurs, and on the right-hand side the times when H occurs and only H occurs. So if you can do a little bit of algebra from here, you can know that if you simplify that, you will get R plus S minus 2RS. So now that we have an equation for quantity A, we can compare it to what we have for quantity B. So again, this is the word problem, and we changed it to an equation here. And you can see the difference here is that quantity A has an extra negative RS. Now, if you remember back from the question, or if you just think about probability in general, you know that R times S will always be positive because you're multiplying two probabilities together. So you're subtracting from that original value. What we know from all of that is that quantity B is larger. So quantity B is larger. That actually, fun fact, would represent the times when G or H occurs, including when they both occur. In order to get the probability when not both of them occurs, you would have to subtract an additional R times S. Now, I want to move on to another example here. So this is also a little bit of a word problem. And what we have is two sets of numbers. So as you can see here, we have the first set S, which is 1, 4, 7, and 10. And then we have T, which is 2, 3, 5, 8, and 13. So we're told that X is a number in set S, and Y is a number in set T. When we have the two quantities, you can see here quantity A is the number of different possible values for X times Y. So a number in set S times a number in set T. And quantity B is 20. So when you're looking at this, you want to first make sure you're clear about what a product is. And hopefully you know by now that a product is the result of multiplication. So if we look at this, we can put these two sets of numbers side by side, and you can see if we have 4 options in set S and 5 options in set T, the total number of products is going to be 20. So that is just multiplying the different options. But we have to make sure to look at the question again. The question says the number of different possible values for the product XY. So that means we have to check and make sure that some of the products that we're getting are not repeats. So if we look a little bit closely, we can see that pairs from sets S and T, we have 1 and 8 and 4 and 2. If you multiply those two together, obviously both of them produce the product of 8. That gives you enough information to answer the question, but I will also highlight that 4 and 5 and 10 and 2 both produce 20 as well. So what you have here is a total of 20 possible products of X and Y, but you have 2 sets that produce the same product. So for that reason, quantity A is actually 18 because you have 18 different possible values of X and Y. And because quantity B is 20, we know that 20 is the larger value, and B would be the answer in this case. So hopefully that is helpful. I want to summarize a few points from this video that you can take away for your quantitative comparison questions. The first one is that you should avoid unnecessary calculations and be comfortable working with formulas. So with the first question, we used probabilities and R and S to stand for different probabilities, and you should get used to working that way. The second case is that we should look for special cases. So in the second question that we had, you want to make sure that you identify that you're looking for different products and that some of the products that you get when you multiply are actually the same. So you want to be aware of that, and that would help you answer the question. If you're looking for more information on quantitative comparison questions, I will link to a few other videos that I've done similar to this. If you are interested and need additional help with the GRE, feel free to contact me about private GRE tutoring. I do offer 30 minutes of free consultation, and how it works is tutoring is completely customizable to you. We'll come up with the study plan for writing, verbal, and or quantitative, so focusing only on the sections that are most important to you. We'll have session agendas for each time that we meet, and we can go over some sample questions, different study resources, content review, strategies and examples, and I offer a lot of flexible payment options for that as well. I have a sample review here with one of my students that I have worked with in the past, and please feel free to contact me. My contact information in the description down below if you have any questions about that. I hope you have a wonderful rest of your day, and good luck on your GRE. Bye!